मैं record. Good morning, students. We'll continue our last topic, that is corrosion from metals and non-metals. Students, as we know that corrosion is a process of formation of compound of pure metal by chemical reaction between metallic surface and its environment. Or we can say the slow eating up of metal by the gases and the water vapors present in air due to the formation of certain chemical compounds. Students, as we know, corrosion is an oxidation process. It can cause the loss of metal or deterioration of metal by its surrounding chemicals. The chemicals may be present in air such as humidity, water vapors, which is known as water vapors, or certain gases which are responsible for the deterioration of the metal, right? As we know that this is a general phenomena which we observe around us. Now, there are different examples of corrosion. Formation of rust on the surface of iron, formation of green film on the surface of copper, and the articles made of silver that acquires a black coating when exposed to air for few days. So first of all, the responsible factor for the corrosion of a metal are metal itself, the environmental chemicals and temperature and the design. Suppose I'll take one example of iron. Iron is a metal involved in the chemical process. And when iron get corroded, it is known as rusting. And what is the formula of rust, children? That is hydrated ferric oxide, that is Fe2O3.X molecule of water. And it is brown in color. What happened? Iron slowly reacts with oxygen and water vapors present in air to form a brown mass known as rust. So this is an equation given below. Fe when reacts with oxygen, atmospheric oxygen, and atmospheric water in the form of humidity, it get corroded, and the corroded or corrosion results into rust, which is known as rusting of iron. Next example is the surface of copper, which acquires a green coating due to the formation of basic copper carbonate. This is very important, students. In board exams, the question asks that name the layer which is being deposited on copper metal, that is basic copper carbonate. How it happens? When copper reacts with water, carbon dioxide and oxygen, that is the constituents of air, right, present in air, it get corroded and form a green color layer, green coating on the metal of copper, and this green coating is CuOH whole twice CuCO3, right? Now, similarly, articles made of silver that acquires a black coating, students, because silver, when exposed to air for several days, it reacts with the traces of hydrogen sulfide gas which is present in air and forms silver sulfide, which is black in color. So we think, students, that only the iron get corroded. No, other metals get corroded also, like copper, like silver. Now, what are the factors? As you people know very well, nature of metal, environment, concentration of electrolyte, temperature, electrode potential, hydrogen over voltage, right? These all are the factors which are responsible for corrosion. The last two factors are just a higher level factors which results into the corrosion. These type of factors responsible on in the chemical industries, electrode potential and hydrogen over voltage. No need to go in the detail about this. Till first to four factors we must consider, that nature of metal is responsible, right? Uneven metal surface we can take, presence of salt we can take, and position of metals in reactivity series we can take, environment we can take. So these are the four factors we must consider. You can leave fifth and sixth factor, right? Now, what are the effects of ill effects of corrosion or harmful effects of corrosion? It reduces strength of the metal, lifetime is reduced, metallic properties are lost, and wastage of metal, right? So how we can prevent it? By painting, oiling and greasing, and electroplating, students, right? Paints form a protective coating on the surface of articles, and it does not come in the contact with the moisture present in air. So it behave as a proof, right? It behave as a coating which prevent or rust proof paints are available nowadays, and these helps in preventing the corrosion. Oiling and greasing, you know that both protect the surface and metal against the moisture and chemical. And electroplating, students, it is a very common and effective method used to check the corrosion and rusting. The surface of iron metal is coated with chromium, nickel, aluminium by the electrolysis method known as electroplating. But most important method is galvanization. Galvanization is the process of coating the iron by zinc, right, students? If the surface of metal is being electroplated by zinc, it is known as galvanization. And in case, instead of zinc, if we want to use tin, it is known as tinning, and the process is known as tinning. If you want to use chromium instead of zinc, that is called chrominizing. But the most important, very important process is the coated of zinc on the iron metal, which is very important to us to know, right? Galvanization. Here I'll discuss some questions with you. Suppose state three reasons for the following fact. Sulfur is a non-metal. I have already asked this question from you, right? And magnesium is a metal. So how you will state the three reasons how it is a non-metal? You will give a characteristics properties of a metal and a non-metal, like it is given here. Sulfur, it is a non-metal because it is poor conductor of heat and electricity, neither malleable and not ductile, and it form a acidic oxides. Similarly, you can give the characteristics of metal here. Now the next question is, what is cinnabar and how is metal extracted from cinnabar? Explain briefly. You must know that cinnabar is an ore of mercury, and mercury comes into which reactivity series? Either it is a metal of low reactivity or a high reactivity or a moderate reactivity. So we know that it is an example of low reactivity. So which process undergoes to extract the metal from cinnabar? That is roasting process. And in roasting process, first of all, what we happen? The metal is being converted into, the ore is being converted into metal oxide with the help of oxygen, right? When metal ore is being heated in the excess of oxygen, it becomes into metal oxide. And when metal oxide is being heated, it changes into pure metal, right, students? So mercury can be purified by distillation after that. Now the question arises like, write the electronic dot structure for potassium and chlorine. You can know. Show the formation. You can show the formation because ionic bond formation is there. And name the ions present in the compound, that is K positive and Cl negative. These are some of the important questions which we have done in our latest videos. Now differentiate between roasting and calcination, students. So explain with the help of a suitable chemical equations. How is zinc extracted from its ore? Name two metals that can be used to reduce the metal oxide to the metal. Again, you will differentiate between roasting and calcination, but give a difference by putting a line, not like this in a paragraph form. This is wrong, right? Here I am just discussing about the definition of roasting and calcination. So roasting is a process in which sulfide ore is heated in the presence of oxygen to convert into oxide, and calcination is a process in which carbonate ore is heated in the absence of air to form oxide. So the next question was, how is the zinc extracted from its metal? So you can show the reduction of the zinc with the help of a carbon in the form of a coke. And the next is name two metal that can be used to reduce metal oxides to metal, that is aluminium and magnesium, right? The next question is, the reaction of metal X with ferric oxide is highly exothermic, and metal X is obtained from its oxide by electrolytic reduction. Identify the X and write its reaction with ferric oxide. So student, you must know about the X, and X undergo X with ferric oxide. What is that X? And when it reacts with ferric oxide, it is exothermic. The reaction is exothermic. It means lot of energy is being released. And this X metal can be obtained from its oxide by electrolytic reduction. What would be the X, right? So X must be aluminium, students. Why? When aluminium reacts with ferric oxide, it forms aluminium oxide and Fe. And give reason to justify why aluminium oxide is amphoteric in nature. You have to give both the reaction with NaOH and HCl. And mention the constituent metals present in a bronze. So you must know bronze contain copper and tin. Thank you very much.